All right, the second section of material in Chapter 6 is 6.2, and it's addition, subtraction, and estimation. So what we're going to talk about is how to add fractions and subtract fractions and estimate using numbers that are easier fractions to work with. For instance, if I had that number 33 over 427 like in the last lesson, it's not especially friendly. Is there another close by fraction that I can sort of think about when I think about what that number actually looks like? Does that make sense? Okay. So what we're going to talk about then first is the addition part. So the addition of rational numbers, if the denominators are alike, then what you see happen is that you simply put the numerators together, you add the numerators together, and the denominator stays the same. Okay? And if you have different denominators, you've got to get common denominators to make that work. I want to talk a little bit first about the first one, the like denominators. Sometimes kids want to do things where they add across the top and they add across the bottom. Right? That's a pretty common sort of feeling that you want to have. And that's what we do with multiplication. We multiply across the top, we multiply across the bottom. So why in the world is it that once the denominators match, we don't just add across the bottom? You can do lots of things to show that. One of the things you can do is a real simple picture form. So let me do it down here at the bottom. If you were to have a pie, cake, cookie, whatever you'd like, and you were to split it up into pieces, and I'm making my pie have 8 pieces. And let's say, for instance, that one of you ate 1/8 of the pie, and then another one of you ate 3/8 of the pie, because you were really hungry. It didn't have to be all together. But if you put it together, you can see that when you add the 1/8 and the 1/3 together, you get 4 out of 8, which is 1/2. And that makes sense. It is. Half of my pie is shaded in. Okay? But if you had done what the student maybe wanted to do, and done that 1/8 plus 3/8 is 4/16, that will reduce to 1/4. And you can see very quickly that this 1/4 is not how much of this pie is shaded in. So it's a concrete example to show why in the world it is that it's a one example thing, I grant you. But it gives some reasoning for why it is that we leave the denominator the same. Okay? Now, if the denominators are not the same, of course, we need to get them the same. And one way to do that, there's lots of ways to do that, but one way to do that is to multiply. Okay? So if you notice, you see A times D, which I've drawn over in red, multiplied here. And then you see the other cross of this, the B and the C that are multiplied. And then the denominator is the two denominators multiplied together. That's one way to avoid having to find a least common denominator, which is sometimes perplexing. It just finds a common denominator. It may not be the simplest denominator you could have ever chosen, but it works, and it certainly gets you to where you need to be. Again, you may have to simplify when you're done. But this is one way to do that. Okay? So we're going to take a look at 1/3 plus 5/3 and then 1/4 plus 5/3. So if we've got the same denominator, what does this first one become? 6/3. And then if you were to reduce, it would become 2. The second one, again, one way to do it, and I'm going to do it to show you how this works, is to multiply the first cross, so 1 times 3. Multiply the second one, 5 times 4. And then you multiply the denominators together, 4 times 3. It's called an algorithm. An algorithm is just a simple process for doing something. This one's pretty easy to remember, which is helpful. So if you've got 1 times 3, you've got 3. 5 times 4 is 20. And then 4 times 3, 12. And if I reduce, what do I get? 23 over 12. You probably have learned other ways of doing it, and if you want to do it a different way than what I just showed you, that's fine. I don't have a problem with that. But just understand that some students may not like the way that you remember. So if you're in a classroom and they're struggling to understand this idea of common denominators, try something different, and this is an option of something to try. Okay? All right, mixed numbers. Mixed numbers, I always hated them. I always thought they're unhelpful to work with. They were complicated to work with. The problem is that mixed numbers are the kind of numbers you see in real life. Because I don't know about you, but when you go out and you measure miles, you don't say that I ran or walked or drove 20/3 of a mile. Do you? No, you don't do that. But you might well say I did 6 2/3 mile. Right? That's a mixed number. That's how we talk, and that's how we think, and that's actual real life stuff. Right? So I ate 2.5 cookies, not 5 halves. That's just, we don't think that way. 5 halves is easier mathematically to work with. And so my mathematical mind, when we started working with mixed numbers, said, I don't want to deal with mixed numbers. But it's actually more usable in real life. So we got to be able to switch back and forth between these two different expressions or ways of writing these numbers. So the first one we're going to do is we're going to take 14/3, and we're going to turn it into a mixed number. And the way you turn a number into a mixed number is you just divide. You divide the top by the bottom. And what you're looking for is you're looking for the old-fashioned division that you did in about 3rd or 4th grade, where you looked for remainders. Okay? So 14 divided by 3, how many times will 3 go into 14? 4. And what is my remainder? 2. So the answer would then be 4 2/3. Because you have 2 out of the original 3 remaining. Now, if you're wanting to go the other direction, that is, you're dealing with a mixed number and you need to turn it into an improper fraction to do some calculation, that's why you would want to do that, is because it's more friendly. Then what you do is you take the denominator and you multiply it by the part on the outside, okay, the whole number part on the outside, or in this case it's a negative, but the integer, we'll say that. And then you add it to what's on top. Now, I say add. In this case, this is a negative. Just ignore the negative for me for a moment, okay? The answer is going to be negative. Everything else we do is going to be multiply, add, and then we're going to put the negative on the front when we're done. Okay? So what is 8 times 3? 24. So we did 8 times 3. And then I want to add 5. So 8 times 3, and I have to still write it over the original same fraction. 8 times 3 is 24, plus 5 is 29. Over the original fraction's denominator, 8. And like we said, the whole thing's negative. Oops. So my solution is also negative. Still negative. So I don't have to worry about do I add or do I subtract. I always add. And then we just put whatever sign was in front back in front. Okay. All right, a couple of properties that we want to take a look at. If you've had Math 1, this continues the idea from Math 1 of all the other properties that you have. So you have some properties that say, within whole numbers, for instance, that says you can switch the order of addition and it doesn't change a value. 3 plus 5 is 5 plus 3. It's called the commutative property. You have some properties that talk about grouping things together and how you group them won't change, and for certain operations won't change the value. So with fractions, we have something called an additive inverse property. And what that means is that for every number that you have that is able to be written in fractional form, that you have the opposite of that as well. So that when you add those two numbers together, you get back to 0. Okay? And you guys know how to do this, right? So if I have 3/5, then the opposite is, okay, we're adding negative 3/5. We want to be able to add them together and get back to 0. So if I'm dealing with, let me write that one down since I just said it. So if I dealt with 3/5, it would be negative 3/5. And the reason why is because when I add those together, I get 0. Okay? So you're jumping the gun for me, Lauren, and we'll get there, I promise, but it's the next lesson. When we do multiplication, we have a similar feature, but it isn't the issue of adding two numbers together to get 0. The issue is being able to multiply two numbers and get the number 1. Okay? So right now we're doing the addition part of this, and so we have 3/5, it would be negative 3/5. And we can do this with any number, right? So if I give you something very strange like that 427 number, right? If I give you negative 33 over 427, its opposite is positive 33 over 427 because those two numbers add to 0. And you can do that for any number. Even 0. What would the additive inverse of 0 be? 0, it's itself. That's okay. It's not very exciting, but it still works. It still has the property. We also have the addition property of equality. All the addition property of equality says is that if you have two numbers that were equal to start with, right, A and B over B and C over D, that you can add a number to both sides of an equation or add a number to both of those values, and the value didn't change, right? So I like to think about this one as what happens if you ladies were to go shoe shopping, okay? So bear with me. So Cherish, how tall are you? 5'6". Okay, so Cherish is 5'6" and I'm 5'4". So if we go shoe shopping together and we both try on a 2-inch heel, we're both 2 inches taller, right? But she's still 2 inches taller than I was just like before. Right? It didn't change that ratio. Well, this is equality. So if we were both the same height and we both put on the 2-inch heels, it would still make us both the same height. Different height than we were originally, but the same height as compared to each other. That's all this addition property of equality is saying. And these are used extensively, both of these, when we're solving equations. You guys have done that with algebra, right? How do you solve for something? You add 3 to both sides. You multiply by something on both sides. This isn't the multiplication property, but this is the kinds of properties you use with equations. So we're going to use it with an equation. The difference is I'm going to actually show you 2 ways to solve this problem. You may or may not have seen both ways to do this before. I don't know that having come into college, I had seen both ways of these done before. So let me show you the one that I would have been taught, and I remember being taught when I was in high school and whatnot before. And then I'll show you another option on how to think about it, okay? So the way that I remember doing this when I was younger is you deal with improper fractions. I told you I didn't like mixed numbers, right? So the way that I remember dealing with this is you change everything to improper fractions. You get common denominators. That's what you do, all right? So let's take a look. We've got 2 and 1/2. We've got 3 and 1/3, and we need to change these into improper fractions. So let's start with the 2 and 1/2. What is that as an improper fraction? 5/2. Very good. How about that 3 and 1/3? 10/3. So far, so good. Now, you can deal with either getting rid of the fractions entirely or simply getting common denominators. What would the common denominator be between 2 and 3? 6. Right? So, and you might even get a common denominator on the left-hand side and the right-hand side or something like that. We're going to do it all at once. We're going to multiply each of these numbers to get it to be 6. This is 3 and 3. Okay, so this is the other approach to getting common denominators, the one that you're probably more familiar with than the cross multiply and thing that I did before. Okay, so I have 6x over 6 minus 15. You know what? Let me leave the x alone for now. We'll come back to that in a minute. All right, let's just do this one. We'll leave the x alone. 5 halves times 3/3 is what? 15/6. And then, whoops, 10/3 times 2/2? 26. And the goal is to solve for x, which is why I said I was sort of undermining my own processing for there for a moment. So what would I do next? Add 15/6 to 26. So what is 26 plus 15/6? 35/6. And as I look at 35/6, I have to make a decision. The decision is, am I done? And the answer in this case is no. And the reason is, how did the numbers start?
They were mixed.
Mixed. They were mixed numbers to start with, right? So they need to be mixed numbers to end with. That's how we're going to make that call. If you started with decimals, you end with decimals. If you started with improper fractions, you end with improper fractions. So we started with mixed numbers here. We need to turn this back into a mixed number. How do I turn something back into a mixed number? Divide. All right, so what is 35 divided by 6? 5 with what remainder? 5. So what is this written as a mixed number? 5 and 5/6. Okay. That's what I remember. That's how I remember being taught this idea. Let me show you the other way that you will see this taught. The other way you'll see this taught is you will see this taught to deal with the mixed numbers as 2 pieces. That is, there's a fractional part and there's a whole number part. Okay? So we're going to look at that from this perspective. I'm going to start then with x minus 2 and 1/2 equals 3 and 1/3. And just like on the last problem or last method when I did this problem, my goal is to get x alone. So what I want is I want to move that 2.5 over to the right-hand side. Okay. So I can leave the x on the left. And here's the difference in what we just did before. What we're going to do is we're going to add the whole number parts together. I've got a 3, I've got a 2. They add up to 5. So I'm done with that piece. The parts I'm not done with are the 1/3 and the 1/2. And I do still have to do the common denominator thing, and I've got to simplify those pieces. But I contend that this is a lot less work than the other way, because I'm nearly done. And I know I started a little higher on my screen, but I haven't done near as many steps. I certainly haven't had to do any multiplication of great extent, right? So let me do it the way that I showed you a little bit earlier. We're going to do, oops, my 5 that I had before. I'm going to do 1 times 2 is 2, plus 3 times 1 is over 3 times 2, which is, and what is my mixed number? 5 and 5, 6. I don't really care which way you use. It doesn't bother me either way. And you may really, really like one way versus the other way. But you should be familiar with both of them enough that if a child were to say, that process, whichever one it is just not working for me, they don't get it. That you have that sort of in your tool case to be able to say, okay, well, let's try it this other way. All right? Explain it in a different method. All right. We're going to do the same thing now on a subtraction as we did on the addition. So the definition of subtraction to start with, if a over b and c over d are rational numbers, and a over b minus c over d is the unique value e over f, such that, then a over b minus c over d has a unique value e over f, such that if you were to add the e over f to the c over d, you'd get back to a over b. And I'm just going to use some whole numbers to show you what that's saying so you can see what it's doing. Let's say that you had 5 minus 2. Well, you know what 5 minus 2 is. It's 3. Yeah. Okay? And why is the answer 3? Well, the answer is 3 because 5 is equal to 2 plus 3. And in fact, that's often how subtraction is taught. And we talk about that in Math 1 as well, is this idea of what's missing. Oh, I wrote something wrong. We'll fix it. I said it right. I just wrote it wrong. Thank you. Is this idea that there's this missing piece. What do I add back to something to get what I was missing? And that's usually how subtraction is presented. And it's presented the same way for fractions. The other piece down here this is showing is that if you're subtracting fractions, it's the same as adding a negative. Okay? And you guys do know that. I remember being in 7th grade and my teacher telling me there was no such thing as subtraction, and we looked at her like she was crazy because she just kept saying, well, it's because it's just adding a negative. There's such thing as negative, so it's adding a negative. So the next piece is to do what we did with the addition. So subtraction, when you have like denominators, the b's on the bottom, they just stay the same, b on bottom. And then you change the top, right? You actually subtract the tops. And then if you have different denominators, again, you do this cross multiplication kind of a feature where you say a times b. I said it wrong. A times d. And then you multiply those together. And you do the b times c, and you multiply those together. And then you subtract, because the problem was subtraction instead of addition, and then you multiply the denominators together to get the denominator. Okay? Again, it's not the only way to get common denominators, but it is one way to do so. Okay. So I want to show you, sorry, my numbers are a little bit all slided off. I fixed those in the other slide, but I ran out of time to fix them on this one, on this 6.2 set. I want to show you an example of how to actually use these. Now, you may not think that yards of fabric is all that interesting to a 4th grader doing this or a 5th grader doing this or whatever, but there's plenty of things you could use that would be. So one of the things I want you to be doing as we keep working along is at some point on some test or when you do your presentations at the end, you're going to get to create your own problems. And one of the things that I do is I tell you it has to be applicable and interesting to the whatever grade we're working with. Okay? So if you don't like yards of fabric, you think that would just be eyes glazed over for the boys in the class or something, that's fine. Pick something that would be interesting, that would work, okay? So we could talk about yards on a football field, and then we might actually have some interaction. Okay? So I want to show you an example, though, of how to think about a problem with mixed numbers that you would actually be doing some of this process for. Martine bought 8 3/4 yards of fabric. She wants to make a skirt using 1 7/8, pants using 2 3/8, and a vest using 1 2/3. The question is how much fabric will be left over. And there's several ways to do the problem, so I want you to tell me what I want right now is not how to do it, but how to set it up. What am I looking for? What is my original setup going to look like? We'll get to that in a minute, and I want to talk about that, but I want to talk about what I'm going to write down first. Because I don't think you really want me to add 8 plus 1 plus 2 plus 1. Do you? So what is it I do want to add? The last 3 numbers. And then subtract it from the first one. That's right. So what I want is I want that 8 3/4 to be the original amount I'm taking away from. So if you imagine what you'd really do if you were doing this as a person sewing, so you'd put the fabric on the ground and you'd cut off one piece at a time from the whole yard of fabric, right? The other thing you could do, in the way that I'm writing it anyway, is you could figure out how much total fabric you need and just cut off the leftovers to start with, and then cut your pieces apart. So what we want to add, because this is what you guys suggested, is the 1 7/8, the 2 3/8, which those are friendly because they both have denominator of 8, and then the 1 2/3. Those are the pieces that we want to add together. Now we can do, like what Mackenzie said, we have an option, right? We can do the parts where we just combine the whole number parts and deal with the fractional parts, or we can do improper fractions and change them all into improper fractions. So I want to do the mixed number part because I contend that probably that's the one that you've seen the fewest of. So that you can just see it happen again, and then we'll do the other part of it if I can find a clean slide after that, and you can see how that would look. So I'm going to do the mixed number version first. So if I'm going to do the mixed number version, I need to get the piece inside of the parentheses to combine together first. Right? That's order of operations issue, the way this is written. So I can add together all the whole number parts, right? Okay. So here's my 8 3/4. I'm not going to deal with him for quite some time. But I have 1 plus 2 plus 1, which is 4. That's okay, 4, yeah. And even better, I can actually add the 7/8 and the 3/8 together right away if I want to. What is 7/8 and 3/8? 10/8, which isn't an especially pretty looking fraction, but we're not going to leave it that way. And then I have the 2/3. Now, if you don't want it to be left that way right now, we could actually simplify that now. What do you think? You want to simplify that 10/8? There's 2 ways it can be simplified. What's one of them? I mean, there's 2 things we can do to it to simplify it. One of them is to reduce it by dividing the top and bottom by 2. Okay, so if I do that, what does 10/8 become? 5 over 4. That's not the only thing I can do to simplify that fraction. How else could I write 5 over 4? 1 1/4. And that's helpful because it makes my fractions smaller, and smaller fractions are easier to work with. So if I want to do that direction, which I think is a good choice, we'll do 8 3/4. I have 4 plus 1 1/4 plus 2/3. So I have my 8 3/4. And now I have 5 plus 1/4 plus 2/3. So far, so good? All right, now what am I going to do? Yeah, and again, one way to do it would be this, right? So 1 times 3 is 3. 4 times 2 is 8 over 12. So there's a 5 here in front. I'm still subtracting the 8 3/4. Subtracting it from 8 3/4. What is 3 plus 8? 11. So here's my 8 3/4 minus 5 11/12. Okay, everybody good so far? Okay. Now, I can certainly deal with the 8 and the 5. And we can do that right now. I'm going to, but I'm going to show you that we're going to run into a problem, but we'll fix it. So what would 8 minus 5 be? 3. And to that, I need to add the 3/4 minus 11/12. What's wrong with 3/4 minus 11/12? They don't have the same denominator, that's one of them, and somebody said something else.
It's less than 11/12.
Right, the 3/4 is less than 11/12. So let's get the common denominator first to see that. So if I were to get a common denominator, I can simply multiply the first fraction by 3/3. That gives me a smaller common denominator. And so I'm going to do it that way. I have 3 plus, and then the problem is, like Heather said, this is 9/12 minus 11/12. And that's negative. But what is it if you were to subtract? What is 9/12 minus 11/12? Okay, it's negative 2/12, which would reduce to your negative 1/6, right? So this is 3 plus negative 2/12, or negative 1/6. How in the world am I going to combine 3 and then the negative 1/6? So I'm going to change my 3 into a 2. Imagine what you would do with money, right? You have $3 and you owe somebody 1/6. I know that's terrible numbers because it doesn't work with our coins, but pretend for a moment that it worked with coins. What you do is you'd need to find some change. So you'd take your 2, you'd take your 3, and you'd find change for $1. In this case, we're going to turn that 1, that dollar, into 6/6, because that's the same as the number 1. Right? This is, I haven't put this part yet here, but this is 1, and this is 2, and then 1 plus 2 is my original 3. And then I can take away the 1/6. What am I left with? 2 and 5/6. Dealing with subtraction is a little trickier because this can happen. So none of this happens with addition, right? But dealing with subtraction, it sometimes does. Now I want to show you the improper fraction way to do this, just so that you've seen the other one again in case that's the less familiar one to you. I'll do here at the end. All right, we had the same piece. You know what, let me do that. Oops, let's try it this way. Okay. So if you want to deal with this with improper fractions, that means you need to deal with, well, getting a common denominator first. Well, getting the numbers, I'm saying it right. Getting the numbers into improper fractions first, right? 8 and 3/4, how do I get that into an improper fraction? 4 times 8 is plus 3, 35/4, minus 1 and 7/8 as an improper fraction, 15/8. 2 and 3/8 is an improper fraction, 19/8, which those combine nicely because they've got the denominators the same. 1 and 2/3, 5/3. All right, so I'm going to combine these two simply because they combine nicely before we worry about anything else. So I have 35/4 minus, what's 15 plus 19? 34/8 plus 5/3. There's two options now. So what do you see? What would you do next if you were doing the problem?
I would divide the first one by 2.
Okay, so Brendan noticed that these are both even. So he wants to reduce. Okay. That sounds like a good plan because anytime we can reduce a fraction to a smaller version, it's easier to work with. The other possibility is that you could simply work with it like it is and look for a common denominator between those three. So I think I'm with you, Brendan. Let's reduce it. So if I reduce those by dividing each of them by 2, what does 34 become?
70.
And 8? 4, which is actually really nice because I already have a 4 as a denominator that I was going to have to deal with anyway. Everybody good so far? What is one common denominator, a nice common denominator for these three fractions? 12 would be good, because 3 times 4 is 12, right? So I can multiply the top here by 3. This one would be times 3. And then the 5/3 would be times 4. And somebody besides Brendan, do 35 times 3 for me. 105, good. Because I knew Brendan would do it in his head for me already. 105 over 4. What's 17 times 3?
105 over 12.
Oh, sorry. Yes, thank you. Over 12. Did you say 51? 51 over 12. And then 20 over 12. I'm dealing with much larger numbers than in the other method. But big numbers don't bother. I mean, 105, I didn't have anything that large in the other case. But it's not bad. All right, then I'm going to add the two that are in parentheses. What's 51 over 12 plus 20 over 12? What is it? 71 twelfths. What's 105 over 12 minus 71 over 12? Am I done? I have to put it back. And what else? Yeah, like put it back into a mixed number. What else is going on here? It's not simplified. So even if I could leave it in a improper fraction form, it's not simplified. So can we simplify first? Okay. So they'll both divide by what? 2. All right. So 34 divided by 2. I think I already did that once, didn't I? 17. And 12 divided by 2? 6. Now how am I going to find 17 over 6? Divide. So 17 divided by 6 goes in how many times? 2 with a remainder of 5. So this is 2 and 5/6. And I didn't do it before, and I'm going to do it right now. Yards. Because there were units before, and I was so excited to show you another method I left them off. Of course, I was out of space too, but there's yards. Now they're there. Any questions on that one? Okay.